Hi folks, I've got another great question over here. This is about problem 8 on the WebAssign additional problems in this module. This is module, I forgot what module this is, but this is about the enthalpy. This is the enthalpy problems. Now, let's see, here are three chemical equations, and we know the enthalpies for each of these reactions. And here is a chemical equation for which we don't know the enthalpy, and we want to know the enthalpy. These units are all kilojoules per mole, and the units that we want are also kilojoules per mole, so there are no tricks with units. The mole here does not refer to a mole of any of these chemicals. It just means a mole of this whole reaction. So that's going to be 2 moles of this, 1 mole of that, 2 moles of that. This mole here, same thing. 4 moles of this, 5 moles of this, 4 moles of this, 6 moles of this. It means a mole of the whole reaction. Okay, so anyways, let me tell you exactly what needs to happen here. This equation you need to get by adding these equations together. And sometimes you're going to have to multiply the entire equation by a certain number in order to get what you want. Sometimes you're going to have to flip the entire equation and in order to get what you want. When you multiply the entire equation by a certain number, the enthalpy also gets multiplied by that number. When you flip an equation, the enthalpy also has its sign flipped. Okay? Let me show you exactly what I'm talking about. Here I have NH3. I only have 1 mole of it. Where else can I find NH3 in the available reactions? Only right here. So there are 4 moles of NH3, but I only need 1 mole of NH3. I could multiply this whole thing by 1/4 in order to get 1 mole of NH3. But let me make sure that that's really necessary. Is there any NH3 anywhere else? No, there isn't. So that means it is necessary. I need to multiply this whole thing by 1/4. So what does that mean? 1/4 times 4, that's going to be 1. That's a 1, by the way. 1/4 times 5, that's 5/4. 1/4 times 4, it's going to be another 1. That's a 1, not a 2. 1/4 times 6, that's 6/4. 6/4 is a fraction I can reduce that to 3/2. And then this whole thing divided by 4, it's going to be whatever the calculator says it is. All right, now I'm going to write that down. I'm going to write NH3, a gas, plus 5/4 O2, a gas, makes NO, a gas, plus 3/2 H2O, a liquid. And the delta H is going to be, let me just do this right quick over here, 291.5, negative 291.5, yeah, negative 291.5, so that's going to be delta H is negative 291.5 kilojoules per mole, all right? So that gives me the NH3. I've got the NH3, no problem. Next thing is oxygen. So I need 2 oxygen molecules. Now I've got oxygen molecules here, and I've also already got 1 1/4 oxygen molecules here. This is kind of a problem. I don't want 1 1/4. I want 2. So 5/4 is 1 1/4. Just in case you forgot that from your middle school days, this is 1 1/4. You can actually just ask the calculator about this. It will say 1.25, which is 1 1/4, or you could find the mixed numeral, as they say in middle school, the way I did right here. Now, so that's 1 1/4, but I want 2, so that means I need 3/4 more. I need 3/4 more oxygens. Where am I going to get 3/4 more oxygens? Well, I can't get it from here, because if I do anything with this equation, I'm going to ruin my 1 NH3, because this is the only place for me to get NH3. So I'm going to get that oxygen from somewhere else. There's no oxygen here. This is the only other place to get oxygen, so I'm going to get it right here. I'm going to multiply this whole thing by 3/4. All right? So 3/4 times 2, that's 3/2. So this is going to be 3/2. 3/4 times 1 is 3/4. 3/4 times 2, that's going to be 3/2 again. And then 3/4 times this is going to be whatever the calculator says it's going to be. I'm done with this 3/4. Okay. So now I'm going to write that equation down. So I have 3/2 NO gas plus 3/4 O2 gas makes 3/2 NO2 gas. And the delta H is going to be, I'm going to do that on the calculator, 116.2 times 3/4, which is the same as 116.2 times 0.75, 87.15. It's going to be a negative 87.15 kilojoules per mole. That's kJ per mole. Okay, now I know what you're thinking. You've been thinking, hey, I can't have a fraction as a coefficient on a chemical equation because you can't have like 1 1/4 oxygen molecules. Yeah, you're right, you can't. But we're going to add these equations up, and we're going to end up with this equation, which has no fractions. All right, so the fractions are going to disappear. For now, just consider these fractions as numbers of moles instead of numbers of molecules. Remember, chemical equations can be about numbers of atoms, numbers of moles, or numbers of molecules. They just can't be grams or milliliters, you know. They have to be numbers of molecules or atoms. Okay, so now I have an NH3, that's good. I have 1 1/4 oxygens plus 3/4 oxygens, oxygen molecules. So that makes 2 oxygen molecules, that's good. I mean 2 moles of oxygen molecules, that's good. Now I got to get HNO3 in the products. None of these are HNO3. Where does HNO3 appear in this bunch of chemical equations? Only right here. But see, I only need 1 HNO3. But here I have 2. That means I'm going to have to multiply this whole thing by 1/2. Now notice, the HNO3 in this equation is in the products after the arrow. Also in the target equation, the HNO3 is in the products after the arrow. Therefore, I do not have to flip this. Luckily, in this problem, I did not have to flip any of these. I think you'll find in other problems, especially on the practice quiz which I made for you, there is a necessity to flip one of the equations, in which case you will see that you need to flip the sign also of the enthalpy change. So anyways, here I need no flipping, so 3 times 1/2 is 3/2. 1 times 1/2 is 1/2. 2 times 1/2 is just 1. And 1 times 1/2 is 1/2. And this times 1/2 is that over 2. So I'm done with this 1/2. I'm going to copy this equation down now. I have 3/2 NO2, which is a gas. I have 1/2 H2O, which is a liquid. And this makes 1... Oh, don't worry. Mama is there. Do you hear the baby crying? Yes, Mama is there. They're having a bath, and the baby doesn't want to have the hair washed, so that's why she's crying. I don't even have to look. I already know. So there it is, and then the delta H. The delta H is just half of this, so it's, I'll put a 6 over here, and then it's 8, and then 2 times 6 is 12, so what is that? 68.65. That's negative 68.65 kilojoules per mole. All right, so that's it. Now I'm going to add these up, and I'm just hoping that everything that I don't need is going to cancel out. Here's what I mean. You see how in this equation I have NO as a product? But in my target equation, NO is not a product. I'm just hoping that somehow I'm going to end up canceling out the NO somewhere along the line here, okay? If I don't end up canceling the NO, then I'm going to have a problem. I have to start over again. All right, so let's go. I'm going to add all these guys up. This is an addition problem. Let me add them up in a different color, so this could be easier to look at. Because you know, my handwriting, it's not. Yeah, all right. So yeah, it's not great. NH3 gas, I want to keep that. Let's tackle the O2s. I got 1 1/4 O2s. I got 3/4 O2s. 1 1/4 plus 3/4 makes 2 O2s. Addition of fractions. Do you remember that? Most of you folks are trying to become nurses. You nurses, I know you're pretty good with the math. Am I right? Pretty good. Probably doing a lot of mental math over there on the hospital floor, if you're already working in a hospital. Okay, so I gotta stop babbling. What else I got here? So I'm done with these guys. I'm done with these guys. I'm done with these guys. What about this NO? Do I have to copy down this NO here? Well, let's see. I got 3/2 NO. Any more NOs? No. Here I have 1 NO. Here I have half an NO. 1 plus half is 1 1/2. 1 1/2 means 3/2. So this is 1 1/2. They cancel with this 1 1/2. Boom! Because 3/2 means 1 1/2. All right, so there they are. Those are gone. They cancel. Things that you see in the products will cancel if you see the same things in the reactants. So that's good. NO2. I got 3/2 NO2 here. Any more NO2s? No? Okay. I got 3/2 NO2 here. I mean, they cancel. Boom. I got half a water. I got 3/2 water. Okay, here's a problem here. Got a little problem here. I have half a water here, but 3/2 water. So this half of water is only going to cancel with half of these. 3/2 means 1 1/2. So that half is canceled with this half of water. 1 water remains. Okay? So draw the arrow. 1 water remains. So that's H2O, liquid. And this HNO3 remains. HNO3, aqueous. Now I'm just hoping that this H2O and this HNO3 is what I wanted. Let's go look. Boom! H2O liquid, HNO3 aqueous. One of each. That's what I wanted. So then we're done. What does that mean? That means that because this is the addition of all of these guys, and because this is what I wanted, I know that these enthalpies, which I was changing along with the changes that I made to these red equations, these enthalpies are correct. So I should add those up too. Just like I added the chemicals up, I need to add the enthalpies up. So let's do that on the calculator. They're all negative numbers, so that means I can just add them all and stick a negative sign on it. So 291.5, let's see, 291.5 plus 87.15, 87.15 plus 68.65, 447.3. My undergraduate, oh, so this is babbling again, sorry. Okay, so this is the total delta H is negative 440. Oh, actually, I'm not going to tell you. This is something that you should figure out on your own. Yeah, so you add those up by yourself and then stick a negative sign on them, and then that will be your answer. Now, you're going to have to adjust your answer to the proper number of significant figures. Let me just point out to you that this guy is only to the 10th place. These other guys are to the 100th place. When you add, what does that mean? This guy right here is the roughest measurement, being only to the 10th place. These guys are finer measurements, being to the 100th place. What does that mean when you add it up? When you add, remember, the significant figures are not, you don't go and count them. It's not like 4 significant figures here, 4 significant figures here. That's not how you do it. So figure that out, folks. Good question. Thank you for whoever asked this question. Thank you. Now, that's it. Oh, yeah, I wanted to mention, my undergraduate degree was in nutrition, and we had to do a lot of mental math to calculate, let's say, the diabetic diet of some patient. So I'm assuming that this type of arithmetic is old hat to you all also, since you all are, I think all of you actually, are going for health professions too. Anyways, that was an interesting aside, was it not?